This comes out of the combined section here of 11.1 and 11.2. So we're talking about definite and indefinite integrals and the fundamental theorem of calculus. So our first example, we're given this. Integral 6x squared plus cosecant squared x dx. And we're not given any ends of integration there, which means we're really just doing an indefinite integral. We're looking for what's the most general antiderivative of this. So it is, properties of integrals are kind of silly properties. It says you can do, this one and this one separately, which in this case you really would do. To say, okay, well the answer to that first one is just going to be 2x cubed. And you might have to look up, you have a table of integrals on your formula sheet, but basically minus cotangent x is what we get for the antiderivative of cosecant squared. And we have a plus c, because this is really a shortened way of asking for the most general antiderivative. So this would be the answer that we'd be looking for. And if you're not sure about it, you just have to take the derivative and see if you get that answer we started with. Now, if we're asked kind of a similar question, but in this case a couple of differences. So 1 over the cube root of x squared dx. First of all, this is a definite integral, meaning we have some numbers to put in, so the final answer to this won't be a function as that one was above. It'll be just a number, a numerical value. I would probably change this right away to x to the negative 2 over 3 dx. That way, it looks more like a power rule question. So you're going to add 1 to the exponent, which is now going to be x to the positive a third, and then divide by a third, which means actually you end up with a 3 here. Because we're doing it from 1 to 8, we don't need a plus c, because basically what we're going to do here is say, well, this is 3 times 8 to the 1/3 minus 3 times 1 to the 1/3. Now, cube root of 8 is 2, so I've got 6. 3 times 2 is 6. Minus 3 times 1 is 1, and the answer to that definite integral is 5. So even though the questions are kind of similar looking, the type of answer you're looking for an indefinite integral is a antiderivative, whereas the answer you're looking for a definite integral is just a number. Let's do one more, kind of a similar question. Let's do a definite integral again, so from 1 to 4 of t squared plus root t minus 2 over t dt. Now, a lot of people start to try to make this way more complicated than it is. When you divide by t, because that denominator is so simple, you can divide each of these terms by t and be left with t plus t to the negative a half minus 2 over t dt. And we're still doing from 1 to 4. And so if I take that a step further, each of these antiderivatives is relatively easy to do, in that the first one is t squared over 2. The next one is going to be t to the positive a half divided by a half, which means times 2, and then minus 2 natural log of t. I might worry about absolute values, but we're looking at from 1 to 4, and I also don't need to worry about a plus c for the same reason we're going from 1 to 4. So I now just have to put in these numbers. I've got 4 squared over 2 plus 2 times the square root of 4 minus 2 ln 4, and then minus, put in 1 for all these as well, 1 squared over 2 plus 2 times the square root of 1 minus ln of 1. Now that looks maybe scarier than it actually is. Most of these are just simple numbers. Ln of 1 is even 0, so that one can go away right away. And you just are adding together a bunch of values. So 16 over 2 is 8. 2 times the square root of 4 is just 4. 2 ln 4 I would leave as it is, or you could say minus ln of 16 if you like. And then you have minus a half and minus 2. Again, the ln 1 is 0. So 8 plus 4 is 12. 12 minus 2 is 10. 10 minus a half is 9 and a half. So you have in 9.5 minus the natural log of 16 if you stay in exact values. If you start to try to get decimal values, that natural log of 16 is going to be pretty ugly, so I would just leave it just like that.